Now I'm going to discuss the topic is Q. Q is a linear data structure. It is also a linear list of elements in which deletion of an element can take place when at one end, that is called front. Insertion can take place at other end called rear. Okay. I already discussed the topic is stack. In stack, insertion and deletions take place only one end, that is called top. In queue, it has 2 points, that is one is for insertion, another one is for deletion. Okay. Deletion done by front position, insertion take place at a rear position. Okay. The first element in a queue will be the first one to be removed from the list. That is FIFO order. Queues are also called FIFO order. That is first in, first out. Insert will be done by rear position. Delete will be done by front position. Okay. The first element in a queue will be first one to be removed the list. Okay. Take the example, if you want to watch movie, you go to theater means you have to maintain queues. Okay. First people who is enter in the first, he only will get the first ticket. Okay, in counter. Then this method is follow for next one, queue wise, following the one by one. Okay. This is the methodology for queue. Who is going to first, that people only removed it. Okay. That is FIFO order. Next one is algorithm. How to insert item to the queue. And also how to delete item to the item from the queue. Okay. This is the procedure. You take this example. This is the pictorial representation of queue. Okay. This is the pictorial representation of queue. There are 5 space available for to add the elements into the queue. That is n sizes n equal to 5. At the time, front and rear position is pointing only 0. Okay. You consider this is also empty. Okay. Leave it for this A symbol. Okay. You consider this is a empty space at the time of position. Front representing F, rear representing R. Front equal to rear equal to 0. That is, if front and rear equal means Q is empty. You leave it this symbol. You consider this space fully empty. So front and rear also denoting 0. This is called Q is empty. But we have to insert how many elements? 5 elements because n. Q size is representing 5. This is the procedure for algorithm for to adding Q. Q procedure of add Q of item comma Q comma n comma rear. Items I am going to add into the Q, and the size Q size is n, that is n equals to 5. Rear, because adding done by rear position. So here indicating rear value. Next condition is if rear equal to n, then call Q rear equal to n, because 1 by 1 the values 1 by 1 add to the position rear. Now rear is 0. If I adding one element means rear will be incremented by 1, that is here representing 1. Next I adding another element, that is representing rear value 3. Then adding another element, rear value 3. Next adding one element, that is rear representing 4. Then rear representing 5. Now I add the 1 by 1 element. Okay. Finally is rear values denoting rear equal to 5. N also 5. If rear also 5, n equal to 5, then call Q full. Okay. Otherwise, this condition is false. Otherwise, to move to the next line. Now rear equal to 0. If I want to insert one data item, that is called A, I am going to add one item A. Then what be the procedure means? Rear equals to rear plus 1. Rear value is starting value 0, 0 plus 1, value is 1. Okay. Then Q of rear means what? Q of 1. Q of 1 to going to the item, that is A. I am going to add the item at the rear position Q of 1 A. Likewise, again I check the condition. Now rear equal to 1 because rear value adding one data item. So now pointing rear 0 is moved to the 1. So now rear equal to 1. 1 equal to 5. Condition is false. 1 is not equal to 5. So condition is false. So next move to the next line. Now rear value is 1. 1 plus 1, 2. Then Q of 2, that is Q of 2 equal to item. I am going to add the item B. Likewise, I am going to add each by each items in the queue. Next, I am going to add one more item. At the time, rear value is 3. I am going to add C. Likewise, I am adding one more item D, then E. This is the procedure for adding items into the queue. This is the condition. Okay. Next one is deletion. Deletion procedure, delete Q of, that is item comma Q front and rear. Here I am going to delete item from the queue. So I am representing item Q. Then deletion done by which position? Front. So here indicating front and rear. Okay. This is the 4 parameters for delete Q. Here item Q, number of size, rear. Then only check if the Q is full or empty. Here we have to know the front value. Then only you compare the Q is empty or not. So here using this parameter. Okay. If front equal to rear, then call Q empty. I already discussed front very first Q is empty. At the time, front and rear is also denoting the 0. Same value. Very first, when Q is empty, at the time, front and rear value is pointing only 0. If front equal to rear, then call Q empty. Okay. Now, front value is, that is front value is 0. Rear value pointing 5. Front value is 0 because all elements will be added into the queue. No elements deleted. So front equal to 0. But rear means adding. How many items are added? 5 items. So rear pointing 5. Now 0 equal to 5. That is condition is false. So 0 equal to 5. Then call Q is empty. But condition is false. Okay. If Q empty means we can't delete items. If any items into the queue, then only we have to delete it from it. Okay. Otherwise, we can't do anything in this queue. So, first check if Q is empty or not. If empty means no process, no deletion process. If items in the queue, then only we have to delete item from the particular queue. Okay. This is the condition false because front value is 0, rear is 5, 0 equal to 5, the condition is false. Then move to the next. Front equal plus 1 equal to front. So front value is 0, 0 plus 1, 1. So now front is 0. Now adding one element, increment by 1. So pointing front equal to 1. At the time Q of front, that is Q of 1. Q of 1 pointing the element is A. A will be deleted from the Q. A move to the items. So A will be deleted. Likewise, then again this process will be processed. At the time, next continue the looping process, continue to the next. Now front rear, now front value is 1 equal to 5. This condition is also false, so next move to the next question. Now front value is pointing 1 plus 1, that is front value is 2. Q of front, that is Q of 2 pointing, which item? Item is B. B going to be deleted. Okay, this is the procedure for delete. Likewise, the elements are deleted one by one. This procedure. Q is a linear data structure. In Q form, this is the Q form representing FIFO method. That is first in, first out. Okay. That is who is form the Q first, who will be deleted the list. Okay, who will be removed from the list. This is the procedure. In this methodology, we have to use two for, that is front and rear question. Rear going to use for the addition, front going to use for the deletion. This is the procedure for add Q, then delete Q. Okay. Next one is circular Q. Circular Q, what is the necessary, what is the need for circular Q means drawback of Q. Okay. What is the drawback means? In this example, I am representing n value 6. I am added the elements, 6 elements into the Q. Okay. Now the rear quotient pointing 6. Okay. Then front will be, I am going to delete the A element. At the time front position is 1. Then I am going to delete the next element, that is at the time front value is pointing 2. Likewise, we have to delete some elements. If I want to add one more element, okay. If I am going to add one more element, that is G. G means I check the conditions. What is condition? If rear equal to n means Q is full. Rear value is also 6. N value is also 6. So condition is true. Q is full. At the time we can't add one more item to the Q. But manually we checking means this place also empty because we remove the list A. Okay. At the same time here also we remove the elements already B. So these two places are now empty. In these conditions we can't represent this place is empty because rear and n values equals means Q is full. So if I want the place, if I want to insert one more item, if I want place means what will be the next procedure, that is shifting process. That is shifting process. Here this is there are two places are empty. So I am going to move the C here, D here, E here, F here. Likewise, I have to move one more place, that is here C, then D, then E, then F. Likewise, I am going to move the elements. Okay. But in the shifting process, processing time also waste. At the same time, to take memory for shifting to. So, to overcome this problem, we have to change the methodology Q to circular Q. Then what is a circular Q means? In linear representations is going to indicating the rounded form, that is circular form. Okay. Circular form means what? In this last example, we are representing the linear form, standing form. Here, just change into the normal Q into circular Q. Okay. Circular Q means what? Here already same method, that is n equal to 6. I am going to add one by one items, same method, that is This is the procedure for to add element to the circular queue. Okay, that is now pointing real value 0. So 0 plus 1 mod n, that is 1 mod n. 1 mod n. N value is 7. 0 to 6 equal to 7. Okay. 1 mod n. Less value means the answer is 1. So in this position I am going to add the element, that is A. Likewise I am going to add another element B. Likewise I am adding C. For example, I am going to add a third position or next element means now rear pointing the value is first is 0, then position is 1. Next second position I am going to add a 2, then 3, 4, 5, 6, then 7. Okay. Likewise I am adding 1 by elements 1 by 1. Now I am going to add the one more element. At the time rear value is pointing 3. Okay. Now the condition is 3 plus 1 mod n, that is 4 mod 7. Okay. This is the compare this two numbers. This is one is less value, so answer also the 4. Mod operator means what? Divide the elements. What is the remainder? That is the answer. Okay. Here less value. So take this is the main value. At the time that is mod n. What is the value? Just add to the real value. Likewise I am adding D value, then increment 1 value, that is 5 mod n, answer is 5. At the time I am adding E, then 6 mod 7, this also F, then 7 mod 7. At the time what is the answer? G. Okay. Likewise I am adding the normal elements into the queue. Okay. In case if I want to add one more item, if I delete the elements from the queue means what? The front value is 0. If I increment the front value means front value will be 1. I remove the 8th element. Likewise front value equal to 2. I remove the bth element. Okay. Now in old in queue methodology we can't use this place because after only shifting only we can use it this place. Okay. But in circular queue after deleting A, okay, after deleting A, front value will be 1, rear value is pointing 6. Okay. In this time I am going to add item, that is H. Okay, I am going to add H to this position. How is it possible? Means here rear equals to rear plus 1 mod n. Now rear values at the final rear values 6. Okay, 6. Six plus 1. 6 plus 1 mod n, that is 7 mod 7. Okay. The answer is remainder values remainder is 0. Okay, 7 divided by 7 we will get the answer 0. Okay. So 0. So at the 0th position we have to add the item what? H. Likewise, we have to use the circular queue process. In queue, we didn't use the remaining space, but in circular queue, we can use the place for another element. Here, we don't use the shifting process, and also we have to use the memory very effectively. That's why we have to use the circular queue methodology.